Solve the simultaneous equations. You must show all your working. We have y equals 5x squared plus 4x minus 19 and y equals 4x plus 1. Now, most of you might think that we can't solve this because usually when you solve simultaneous equations, you have one y and one x only, as in you have a y here and an x here and a y here and an x here. But this time we have an x squared. But remember, we have 3 different ways that we can solve simultaneous equations. Just because we can't just add them and get rid of one variable doesn't mean that we can't solve it. One way that we can solve this is to do y equals y. This y equals this y. This means that 5x squared plus 4x minus 19 equals 4x plus 1. And we can try and rearrange the equation so that we have x as the subject of the formula, because by doing this, we got rid of the y variable. So let's try and move all the x's to one side. So we can do minus 4x to this side to get rid of the 4x, and we must do the same to this side. So we have 5x squared, and then 4x and minus 4x here cancel out, so we have minus 19. On the other side, we also have 4x minus 4x that cancels out, so we have 1. If we move the minus 19 to the other side, we plus 19 to both sides. So we have 5x squared equals 1 plus 19, which is 20. And then we can divide both sides by 5 to get rid of the 5. 5 and 5 here cancel out because 5 divided by 5 is equal to 1. So we have x squared equals 20 over 5, which is equal to 4. And we can get rid of the square on the x by doing the opposite of square, which is square root. So we square root both sides, and we have x, because square root of x squared is equal to x, equals 2. But notice that we should have 2 values of x. Whenever we square root something, the negative value of the value also works. This means that we have plus 2 and minus 2. So our 2 values of x should be 2 and minus 2. And then we can use these values of x that we just found to substitute back into either equation to get the value of y. For x equals 2, I'm going to substitute it into this one because it's simpler. For x equals 2, y equals 4 multiplied by 2 plus 1, which equals 8 plus 1, which is 9. So for x equals 2, y equals 9. For x equals minus 2, we have y equals 4 multiplied by minus 2 plus 1, which is minus 8 plus 1, which is minus 7. Therefore, for x equals minus 2, y equals minus 7. We can also do this the popular way, where we add the 2 equations together to get rid of one of the variables, because right now, notice that the y here and the y here is the same, and the 4x and the 4x here is the same. This means that if we subtract the 2 equations, we should remove those variables, and we should be left with x squared. If this is equation 1, and this is equation 2, if we do equation 1 minus equation 2, we have on the left-hand side y minus y. And on the right-hand side, we have 5x squared plus 4x minus 19 minus 4x plus 1. Y minus y on the left-hand side is equal to 0. We can't combine 5x squared with anything, so we have 5x squared And 4x over here and minus 4x over here will cancel out. And we also have minus 19 and minus 1 when we multiply the minus inside. So we have minus 19 minus 1, which is basically equal to 5x squared minus 20 equals 0 on the other side. So we can move 20 to the other side by doing plus 20 to this side and plus 20 to this side. So we have 20 equals 5x squared, and we can divide both sides by 5 to get rid of the 5 here, because 5 divided by 5 is equal to 1. So we have 20 divided by 5, which is 4, equals x squared, and again we can square root both sides to get the value of x. For this we should get x equals plus 2 and minus 2, and then we can do the same thing to find our value of y by substituting these values of x into this equation or this equation to get the values of y that correspond to each value of x.